4. Okay, so welcome everybody. Earlier this year, I've organized a series of talks by scientists on the positive aspect of climate change in order to inspire artists to submit an art piece to the fall show at the Corvallis Art Center entitled, "What Will Nature Do?" This new series of talk is by scientists who are also artists in order to explore how science can inform their art as well as how their art might inform their science. And this particular series is co-hosted by the Artside group led by Jerry Bartholomew and with also an eye by the Art Center, which considers this a follow-up from the previous talks. So the first speaker is Dr. John Selker, who is an OSU Distinguished Professor of Biological and Ecological Engineering. He has been with the College of Ag Sciences at OSU for 29 years. Goodness gracious. He is co-director of both the Center for Transformative Environmental Monitoring Program and the Trans-African Hydrometeorological Observatory, as well as PI of the openly published Environmental Sensing Laboratory, currently employing 40 undergrads. John is also the president-elect of the American Geophysical Union Hydrology section of 7,000 members. And like he says himself, or after other things, only academics worry about like papers and things like that, publications. His focus area include environmental instrumentation, groundwater processes, and eco-hydrology. He has worked in more than 20 countries across 5 continents, and he loves making things like wooden bowls. And so John, the stage is now yours.
Thanks, and I want to apologize to the speakers that come after me, because I will address all of the issues of science and art, and so I come out with a fairly complete picture here. But let's first start with a little bit of the nuances of the craft of getting the wood to make bowls. So this is the act of collecting. This is a large oak tree that had fallen down, and it seems to be rolling down the hill. So gravity.
Oh, no.
So that was my car. Gravity definitely works as we might expect, and being a physics major as an undergraduate, these things have meaning to me. What I'm going to do is give a little talk that asks more questions than it gives answers. So I'm expecting it to hopefully stimulate thinking. These are not questions that are original or profound in a sense. They're just questions that come to my mind oftentimes, and I thought that might benefit y'all as well. So let's see, I think I want to do the more and hide floating panel, probably, right? Go away, floating panel. Okay, so one of the questions that I think about often is, why do we do hard things? So we as humans are drawn to challenges. So on the left, I'm harvesting the wood from a 300-year-old oak tree by hand and with pulleys and winches, and you get pretty sweaty and tired, hopefully not bruised. And on the right, putting a well into the floodplain of the John Day River to see how the dynamics of groundwater work there. In both cases, on the face of it, sweaty, hot, difficult, and yet they are what define what we seek in developing our humanity. It is where we find ourselves. A second piece of the mystery of being a human is why we find nature beautiful. Nature, be it looking at the mountains, looking at a snow crystal, looking at a large field of snow, looking at the globe from a distance of the moon, we find nature to be beautiful at a level of being healing. And we have to make a decision at some point. How do we interact with that beauty? How do we interact and enhance or maybe mirror, or maybe provide a focal point for that beauty. Why would we do that? One of the things that humans long for is communication. And by creating a focal point and a lens through which we see things, we create deep communication, expressing those things which bring joy to us and those things which we hope will resonate with others. Now in science, this is the injection of rhodamine dye into a column of otherwise quiescent water. And what we're seeing are the turbulent patterns due to thermal convection within those columns. And it's just crazy beautiful. You know, just when you were watching it evolve, it's just absolutely stunning. And basically anyone who walked in the room that day would just be mesmerized by this set of processes. These are processes which we can explain with differential equations, which end in so doing, the very chemistry and water which we enjoy and live with is often the result of transformational cleaning and transport processes that fundamentally rely on the physics shown here. And it's beautiful. This is the same sort of column, but now we've suppressed the convection with by packing it full of basically baby diaper material. So it's a very, very hydrated polyacrylamide. And what we can do here, well, first off, what we saw is this rhodamine then diffused like a coral through this stuff. And it was just, again, very difficult to capture in a picture, but absolutely mesmerizing. And of course, this was very important for groundwater studies because now what we can do is take a well and we can freeze in space the water and let the water from the aquifer diffuse into the well locally and not mix. And so then we can run a probe down our polyacrylamide, which, as you know, if you've had kids, is very gushy, slippery stuff. And basically you can sample the entire chemistry of the well as if you were in the aquifer rather than being in a well. Anyway, what we find is that the beauty of these processes drives our imagination and it drives our ability to visualize what might happen under the earth. And that process of visualization is in part the process of looking at a tree or looking at a rock, if you're Michelangelo, and saying, what is in that rock? Where is the sculpture in that rock? Now, beauty is also a reflection of time and space, and the creation of an object is a process that requires time and takes up space. I was asked to make an urn for a friend of mine who was dying of brain cancer. And it's a phenomenal task. I don't wish it on anyone. But she was a gardener, and so this is a hazelnut, a large scale, well, not from an acorn that I made out of walnut in this case. So it's kind of a little bit of a mixed metaphor there. But the process of evacuating the wood from the interior of this was extremely rich, and it continues to resonate. And so when we are undertaking activities that are dedicated to others, and fundamentally science is dedicated to the future of understanding, and art is dedicated to the experience of the viewer, this is where I tend to find meaning. Now, not everything goes well, and Lori certainly would attest to that in my machine shop. And this is a series of my earliest bowls that I made that were large scale. These bowls start off as pieces of oak that weighed between 150 and 300 pounds. and you turn them, and as we'll show in a little bit, it's a very intimate process of turning. So you're right up with the bowl. And then when you spend a lot of effort finding the tree, cutting the parts, bringing them home, trimming them up, blah, 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 and then they crack. What do you do? And so here I am trying to fix all these cracks, hopelessly trying to fix all these cracks. And so what is the joy of learning? And is failure a gift? And how does that gift give in the context of art? The selection of a form in the process of creating that form is the result of years of failures, years of surfaces that weren't what you find. After you lived with them, they weren't what you wanted. And I can look at each of these pieces in particular and see that sort of failure very clearly, as in addition to the cracks. But the interesting thing about turning is I'm constantly removing. It's removing the last shape and replacing it with a new shape. And I'll say that if you're heading for perfection, you will stop before you start, because you cannot pass a single sharp tool across a piece of wood and get exactly what you want. But is that lack of perfection meaningful? Is it where we draw meaning? Is there learning without making mistakes? Going back to the issue of hard work, are we fascinated with struggle, or are we seeking passivity? Now, science and art often both use technology, not always, but even it's Goldberry, what's the guy who does the rock layout?
Andy Goldsworthy.
Goldsworthy. Anyway, if you've seen his work, phenomenal. Go find it. It's unbelievable. But it's at the end of it, he takes rocks, he stacks them up in beautiful ways, or sticks, or whatever, just incredible stuff. But at the end of the day, he takes a picture of it. And it's the picture that is the record, that the only thing that the viewer ever will experience. The art itself is transitory. So the point is that even in the most basic of art, there's almost always a piece of technology. And the amplification that tools provide us are fundamental to understand the current human experience. What, is there a limit? Well, they always say we went to the moon. And then the question is, what did we create? I didn't make my lathe. I could have, I suppose, welded it together, but still, I wouldn't have made the steel. I wouldn't have made the original concept. When we advance science, when we advance art, I like to think of it as a bricklaying exercise. That I find a brick, it's a nice solid brick. It's a really good, cute little brick. And I can put some mortar down, place it in its context, and it will play its role, and it will have its beauty. In the same sense, I don't take credit for the beauty of what I make. I am a participant in it. And we are all participants as scientists in a much larger effort. And the beauty of certain work only becomes apparent very much later, and maybe never. And so, we're currently in the midst of a great experiment of science, the messenger DNA, and just indicating how do we fit that profound engagement of tool making into our experience as human beings and our contribution in that context. And I often look at my teams in the field, and here we're laying fiber optic cable in the John Day River. Team of people. Austin Hall is the one with the GPS mast in his hand. So we've got this super unbelievable precise GPS that somebody made for us. The fiber optic cable is made in Switzerland. The machine to read the fiber optic cable is made in England. And the team is actually a team assembled from around the world. I was teaching a class in the river. And so we had Germans and British and French, et cetera. And so we had a team that really spanned the world. But who is the author here? And I think that when we look at art and we look at science, we often really pay a lot of attention to who the author is. And I think it's really misplaced, in my opinion. And I am, in my role in the American Geophysical Union, there's so much discussion of who gets what award. We spend so much time patting each other on the back and who gets what recognition. But who in this picture should get the recognition? So let's take a look at what happens here when you start with a block of wood. And now this I've already kind of trimmed up. I took the piece that rolled in front of the car, and maybe this is a different piece actually. You put what's called a face plate on it. And then you hop around the other side of the house and you put you prepare the lathe. And this one I hand lifted the lathe. Many of the pieces of wood are so heavy that I have a crane. But now you can see the sun is starting to slowly get dimmer. The wind is blowing. And I'm approaching this piece of wood, trying not to stand on the axis of the wood, because if this piece of wood has an internal defect, it can blow up and then you could die, which is a not preferred outcome. Now I'm starting to shape the outer sections. My neighbors come by and chit chat for a bit. And basically what you're doing is bringing a single steel knife to the surface of the wood as it's spinning. And you're literally peeling it like a carrot and just peeling off tiny ribbons of wood. And you're going to take that entire block of wood, all but the last few pounds, which we left as the bowl, and you're going to turn those into just little wood chips. So now we're just doing the final cuts, just kind of trying to look at the piece, trying to really get a sense of where the curvature is, what needs to be kind of adjusted and tweaked, and trying to relate to the wood itself and the pictures in the wood. It's very challenging to memorize the wood while it's turning. And so to remember exactly what the different patterns are and how they emerge in 3 dimensions is one of the fun pieces, because when it's turning, it's just a blur, right? Mm-hmm. See if I can get to the next slide or not. Now, one of the most fundamental questions in science and art is, when is a piece done? This is a piece of cherry wood from Chad Higgins' farm. And you don't see it because it's very well hidden, but actually the entire left side, not where the crack is, there's a visible crack, but there's an invisible crack where the entire left side flew off while I was turning on the lathe. And at that point, I decided it was done. And I looked at it and I said, you know what, that is done. It's this very, I was still working towards the ideas, but I had already kind of finished the interior surface and saw that the interior surface had a very interesting conversation going on with the rough bark and the rough shape that the chainsaw had made. And I decided, well, that's done. And that decision is, of course, one of the fundamental decisions of art, but it's also one of the fundamental decisions of science. And there's a lot of controversy surrounding, when is an article really done? And is there such a thing as a completion within the world of science? And I claim no. The point is that science is continually a community process adding to each other's conversations. And any notion that you have finished in science is myopic. That said, we do finish an individual brick, we finish an individual paper, and that has a sense of completion. Identifying where you are in that path is very tricky, and many a PhD student will spend an extra year or 2 on their PhD trying to find what it means to be finished. And then oftentimes we like to do things perfectly, but many times we need to do a lot of sketching in art. And I can show you my notebooks, which are filled with sketches of different forms of things I've turned and things I've made instrument-wise. And here's a sketch of how to of a fiber optic layout where we're connecting different fibers together in certain specific ways and taping them down and labeling them. And it's ridiculous. This is not what we call great, scientific method, but it works perfectly. And so sometimes perfection, again, is not what we're looking for. And this is done. This is done for the need that was shown. Here's another kind of different approach where we wanted to take a little more time, try a new method for coiling the fiber optics into a cooler. And we'd never done a lot of the things in this picture, and doing it really carefully and well and making it sort of pleasing actually is very important, so that the team really respects what's happened. At the end of the day, there's a sense of elevated attention due to the quality of work. If something is done sloppily, if something was done without thinking, then everything will be compromised. And so in science as well as art, there's that intention that really permeates the process, and it shows up in how things are done. This is a bowl which really surprised me about when it was done. This thing, normally I would have taken out the inside and had a bowl. This bowl weighs about 40 pounds. It's a large piece of oak and it's very thick. It has these huge fractures in it. And so, as I mentioned earlier, fractured bowls are dangerous. They can fly apart on the lathe. But somehow I got to this place with this particular bowl, and the shape of the inside and the shape of the outside were just like, oh my God, it's done. It really shocked me and surprised me. But I think being ready for it to be done, being always observant of when something is done, and looking for that opportunity, and it works in science as well, to look for that opportunity to, and I always say that you can write a paper about an experiment that takes 10 minutes if you've really understood what the experiment has to be. You can do experiments your whole life and not write anything up if you're just hunting in the dark. So being prepared and looking for what completion means is really a key piece of doing any sort of activity, science or art. And I will say that experiments have beauty. And this on the right is an actual physical experiment about 8 feet wide and about 5 feet tall, with water flowing and going over this textural interface in the media. It's a very complicated unsaturated flow process, but rather pretty to look at. And then in the left, we have a numerical simulation of a very similar system. And so you can see that we aesthetically, scientists respond to drama, visual drama. Now this is a diagram that took me quite some time to generate. But basically what it did for me, and you step from left to right in the sketch. And what this sketch works through is how water evaporates from deep water tables in deserts. And so it basically allows you to, it structures your thinking and allows you to solve the problem of arbitrary location, how the water moves from the water table to the surface. And it turns out that this had been widely misunderstood. And so this is out of a paper I wrote about 2 years ago. And the act of making the sketch, the act of creating the diagram, of course, you had to work through everything. You had to identify exactly why each line ends where it does. And so I think that one of the things that humans don't spend enough time thinking about is how we develop ideas, how we develop meaning. And one of the critical methods is writing. And I always say that writing is where ideas emerge. You may think you know what you're talking about, but until you've written it and looked at it critically, you don't, probably. When we write, everything changes. Similarly, when we draw, you have, you can just imagine poor MC Escher and his nightmares about, going upstairs. They never ended. But when you really draw carefully, they do end. And so the act of drawing is a part of the human thought process. It's also part of the human communication process. But I, at this point, want to focus a little bit on how it works in terms of our imagination and discovery. Now, one of the things I want to interject here, because we have now drawing, we have woodworking, we have some science, is what would Leonardo say? And when we look at Leonardo da Vinci, we always say, oh, the Renaissance man. I kind of look at it differently. John Baptiste recently was interviewed, and you may have heard the interview, where he said he doesn't believe in genres of music. I thought that was really interesting. I think we way overemphasize genres of music. I think we overemphasize the difference between music and performance. I think we overemphasize the difference between performance and experimentation and between art and science. To me, I go into my shop and one day I'll be making a scientific instrument and the next day I'll be making a bowl. They feel very similar to me. Here's some more experimental data from Mark Rockhold and Rocky Yarwood and Mike Nemeth, showing on the left experimental observation of bacteria growing over time in unsaturated soil and how they grow out in a horseshoe shape. And then we were able to capture those same effects in a model and be able to capture what was causing this. And it's fundamental to the colonization processes of bacteria in soils and how the bacteria actually move water. And what they're seeing here is that it's bacteria causing a drying region in the core of the colony, and that pushes them out to the perimeter. And that's where the action is, on the perimeter. Okay, I don't know how that picture got in there. That was supposed to be somewhere else. So, and here's more about looking at the bacterial numbers. Where are the bacteria? Experimental model. And then how much food they're eating. This is the glucose that they're chewing up and where it shows up. And once again, I mean, you know, you just have to say that, you know, nature, of course, makes beautiful forms. And when we understand nature, to the degree to which we understand nature, we can reproduce beautiful forms and we can create beautiful forms ourselves. Very, very, very often reflective of those same shapes in a natural context. And this is, you know, I needed to do a special probe for understanding why snow melts. And so I had to make a probe where I've actually wrapped this with a few kilometers of fiber optics. This is a tightly wrapped fiber optic around a very thin pipe. And we go, but one of the things about this, this was done in Switzerland when I was on sabbatical. Everyone who came into the shop, and they had this wonderful shop, and of course, Lori knows that I would be in that shop, and I was in that shop, and I played with everything. And I would just make stuff that I was satisfied with. And, you know, so one thing about this pole, it just looks gorgeous. It just had this glistening, you know, kind of taking a pattern and repeating it. We know in music or in many things, create something much richer than one instance. And wrapping a few tens of thousands of times a fiber optic around this create this glistening, you know, kind of deeply opalescent object. And then we go to the field and we stuff it in the snow. And on the right, actually, that's Marc Parlange stuffing in one of my other probes that I made, which is a gas movement probe. And those are really beautiful, tapered very gently with a beautiful shiny brass tip on them, so that when you push them into the snow, they displace the snow and keep a nice tight seal, so the gas won't be flowing along the rods. Anyway, we do this. This is the way we do work. We make things that we are pleased with, that fulfill the functionality, but also respond to the environment where we're going to be working. In this case, we're at over 10,000 feet elevation in very, very cold conditions. So everything has to be chosen accordingly. And then we take measurements, and then we get these cool data. And this is, I won't go into the details of what this data is, but it shows specifically the heat transfer into a snowpack, which is what we're trying to do. It's very tough. So nature, be it snow melting or wood rotting, is an interaction between processes. Oftentimes the powers of life are behind those processes, not in the case of snow so much, but in the case of this wood, what we're seeing is a maple tree that had the core of which had burned out many years before. And then the tree was trying to grow and the fungus was chasing it. And so the bark is the upper edge of this piece. That's what's called a live edge bowl. So that was where the bark was. And then the fungus is coming towards us. And it's marching in. And of course, the fungus is having its own problems. It's fighting against other types of fungi. So they're making these boundaries between different fungi, saying, this is my turf, that's your turf. And so they're trying to poison each other. And so here we have a snapshot of life where multiple organisms are responding to their environment and leaving behind the fingerprints of their processes. And obviously, I didn't create the beauty of these patterns. They are in the wood. The role here is to visualize what they might look like, to visualize where they might occur, and try to bring that out and bring the drama of these natural processes to the viewer so they can sort of get a sense for once again, the intrinsic beauty of nature in its complexity. Now, last night in preparation for the seminar, I felt that I had to turn a bowl for y'all. So I've got that bowl here. So we'll just take an escape here for a second and see if we can get back to not sharing. So let's see, I don't know what's going on. My screens are all really wacky. I guess, can you guys see me? I guess you can probably see me, huh? I don't know. Can you see me or not?
Yes, we can.
Okay, so this is the bowl. And what it is oak that was infested by mistletoe. And you've probably seen mistletoe infestations in trees. Romantically important, but for the trees, it's no such ride in the park. The mistletoe actually is invading the wood and pulling out nutrients, and so the tree is trying to fight this thing off. Now the problem is that the mistletoe then creates emergences where the mistletoe leaves and branches come out, which creates a defect in the bark, and then the ants come in. And the ants come in and perforate along the lines of the mistletoe invasion. And what you end up with is this incredible pattern of and if you look really closely, I don't know if you can see it, the grain is like turbulent, is like a turbulent scene of the oak going in every which way. And so if you looked at, so with this, the project was to find the right tree, to see the bowl within this lump, and this lump looked like just a giant black cauliflower. I mean, there's ill-defined and really doesn't tell you much about what's going on inside. But once you get used to cutting them open and stuff, you can express it. And then how then do you take that substance, the oak infested by mistletoe, and how do you turn it into something which brings out, hey, Scott, this is your tree. This is Scott McClure's tree. So anyway, how do you bring out what happened to poor Scott's tree in such a way as to tell a story and to take the viewer to a place where they can both see the forces that are represented, but also see that this would be a lovely place to put your fruit, because it's going to have natural ventilation of your fruit, and so things won't spoil as much. So it has we don't avoid function just because we have beauty. So I think the fundamental contrast you should be thinking about is craft versus art here, and put that in the context of my discussion of genre. And I think that it's equally uninteresting to fuss about genre. Now, the same concept of the forces can act in a piece of wood that doesn't have so many challenges. And so this is a maple tree. And what I love about this is that the stresses at this interface here. Let's see, I want to go there. So the natural kind of environment as this tree grew, it was pushing out its bark, and it had some tensions and some compression, and it was fighting those. And so that's when you get the figuring in the maple. And so the maple, what I like is that the combination of the revealed surface at the edge of at the bark line, how it projects in time. This is time this way. So there's time and space, and then you can read the tree in that sense. And so I think that that to me, that's always, you can't help but end up with something beautiful if you play with time, space, and nature, and what you can do. So those are a couple of bowls, and I'll just go briefly back to the PowerPoints and just put up a few more bowls. This is another bowl that was a gift to my brother Ted for Christmas or some holiday or other. That had this really cool little hole and defect on the side that really kind of brought the whole thing to life. And then it showed.
You need to share your screen, John.
Oh, am I not sharing my screen? Well, I can see it.
I'm sure.
Sorry, guys. I'll try to be good here. Let me see if I can do this. Share my screen. Share screen. Let's try that. I will share this one. Thank you, Dominique. So this is a bowl that, as I say, was a gift that just kind of showed the interplay of the different branches coming through and how they distort the grain, and then also this invasion here, which I don't know if it may well have been another mistletoe event.
That's a 12-inch ruler, right?
And that's a 12-inch ruler. And this bowl is one that was from a tree that died in Chad Higgins' yard. It's a black walnut. And here you see some of the fungus that finally killed this tree, that light patch there. And you can see it invading here and here and here. But fundamentally, there's just this kind of almost wistful, cloudy, kind of life of this tree that, it was growing gracefully, fighting its little battles, as it were. And in this case, I wanted to make the piece, I don't know how to give it scale, really. That's a coffee cup in the foreground, or I put two bowls in it on my table. It's about, 28 to 30 inches across. And what happens is now we're taking on the scale of the tree itself. And I think there's something very important about that. These trees have scale. We don't just take a block of wood and mill it out and have a non-scale object. This tree had a particular shape and a particular scale, and the exterior of it, as you go from what's the foreground to the background, it is splitting into two branches, and so you're actually seeing the contours of that tree collapse and diverge, as it branched. And so I think there's a lot of information that you lose when you give a clean edge and you get rid of the history of the piece of wood. Here's some more. These are not Scots trees, but these are some more mistletoe pieces that just kind of very funky pieces of wood. And I think a lot of them, I don't know who they'll appeal to, but for me, it's a really just wonderful exploration. And it's not only an exploration of the nature, but also the experience of making them. And one of the things that is not apparent here, which was the most difficult piece to turn here, it's the one that's on the left middle row. And you couldn't see anything. When that thing's spinning on the lathe, you see nothing. You're basically putting a tool into free space, and it's a very eerie feeling. And it also only can withstand a certain amount of stress. And so you can only spin it so fast, and you can only hit the wood so hard with the tool. So much of that craft is super exciting. I mean, it's a dance. It's an experiential growth that, as you keep on turning, you keep on experiencing how to touch the wood and how it will respond. And so the more kind of complicated these structures get, and you can see the middle top row is pretty darn cantilevered there. There's a whole, there's not much wood holding that thing together, right? So turning that is really very engaging. You are 100% there. And so this is the way that the piece that I showed earlier is actually displayed. I display it on its sister piece of wood. I cut that piece of wood in half, and so it sits on its partner. But at this point, I've asked you a whole bunch of questions, and I'm hoping for some answers. So I hope I came to the right place, and I appreciate your patience in my circuitous path through this conversation. But it's been a treat to share my thinking with you, and I look forward to hearing what you guys are thinking.
And thank you, John. That was a great presentation. Really enjoyed it. And if people have questions, they need to unmute themselves and talk. Because for some reason we don't have any chat room for some reason, so I'm going to have to.
And we're not challenged by numbers. There's only a few of us, so feel free.
Yeah,
let's
exactly.
open up your mics and let's hear the chatter.
Yeah.
Okay, I'm not going to be shy. I'll start out with a question for you, John. One of the things that I always think about when I'm doing art and science is how they inform each other, how my process in one is affecting, especially how the process of my doing art is affecting my science. Are you taking anything from your woodworking process that informs your scientific process?
And here, Jerry, I'm gonna be really stick to my guns and say that I don't separate them much.
Mm-hmm.
And let me talk to you about that. So so this piece of wood, when it was drying, it shrank. And why did it shrink? Because water was leaving the pores and the cellulose was contracting. Now, Jerry, what's your science?
Microbiology.
Microbiology. Okay. So maybe you know about there's some really great stuff to talk about there in terms of wood. So there's what's called cavitation in the capillaries of wood. And so when I'm working on some cavitation issues in my science that look at how trees can or cannot recover from cavitation, and how microbiological systems eliminate cavitation. In this case, nitrogen consuming bacteria. You will, and this is something I haven't published, but is really, really cool, is that basically the problem of cavitation is fundamentally the excess of nitrogen. That nitrogen will cavitate, because that's what the atmosphere primarily is nitrogen. And so if you can get bugs that will fix that nitrogen, you will massively reduce cavitation. And what you're going to find now in the literature is that now in the last year or so, they've been finding these nitrogen fixing bacteria everywhere. And why do plants put these sugars into the core of the tree? Why they do it? There's no good reason. It's not for preservative reasons. It's to feed those bacteria, it's to feed those systems so they'll consume. That is all my theory. I mean, honest to God, I have a lot of lab work that I haven't done. But I guess what I do, all I do is think and do, and sometimes I'm thinking and doing how to sample water from a sewer pipe, and sometimes I'm thinking and doing about how to make a wooden bowl, and sometimes I'm thinking and doing about how capillaries in trees work, and that might be while I'm turning a piece of wood, or it might be while I'm thinking about that piece of wood. I don't know. I refuse to at this point in my kind of ripe age. I give up on that notion.
When did you start working on wood?
Well, my dad, you see, I grew up in a different, as you well know, a different generation. And I was the 7th child. And basically, if I went missing for anything less than a week, no one really would notice. And so the operational format of the household was very laissez-faire. Well, my grandfather, who I never met, was a master woodworker. And he, to save time, he had his lathe turning tools and he sharpened them on both ends. These are tools about this long and they're razor sharp on both ends. So you do, then you just flip it around and you use the other side of the tool because it's so handy to have the two pieces of the tool right there. And so my dad, when I was 9 years old, bought us boys a lathe to go in the shop. And the shop was really just a hole in the wall. But we stuck this lathe there. You'd stick pieces of wood on it. Of course, no ear protection, no eye protection, no gloves, nothing. And you spin the wood up and you bring this tool, which is sharpened on both ends, up to the piece of wood. And generally speaking, there was something very exciting that happened next, which is the wood would go flying off the lathe because the tool would grab. So I started turning wood when I was about 9. And we built a house as a family, a 3-story wooden house from ages 10 through about 20. And so I ran a little carpentry business for a while. And so I love working with wood, and I've done a lot of carpentry, and I really enjoy that.
When did you start thinking about making bowls for their beauty instead of usefulness?
You know, I didn't make bowls until about 93 or so, 94, 94. Yeah, I can associate with the birth of our daughter, Julia. We had a broken chair that needed a leg, a little child's chair that I'd grown up with, a maple chair. And it was missing a leg, and I saw that there was a lathe in our shop at school that was stuck in a storage area, and I asked our shop manager, "What do you do with that lathe?" And he said, "Oh gosh, it's in the way." And I said, "Well, do you mind if I store it for you?" And so I stored the lathe, being a good citizen, and then I turned some things, and it was only some year later I kind of said, "Let's try turning a bowl." So it was probably around 95 even. That I started turning bowls. Yeah, Cynthia.
So I'm just curious, I know that you said the science informs you what you create and the wood informs what you create, but are there times you just want to make something out of wood or any other material that just is like, you have this idea and you go for it? I mean, because Dominique has invited us all to learn more about climate change. And, my media of clay, I mean, while I can think of a few ways that I might proceed, not so much. I think of all these other mixed media ways or time-based or some other format to kind of get that time element in there. So I just am curious if you ever think of one, and since you have a potter in your family, I mean, are there times where you think, I want to try this totally different, whatever.
Oh yeah, no, I do mixed media. Thank you very much. I do throw a little bit, not for years, and I really should throw more. I love throwing on the wheel. I make a lot of stuff out of metal, so I have a full metal machine shop. I have a welding systems. So I have gas welding and electric welding, and I do plastic forming. So recently, to do my sewer sampling thing, I made it out of plastic. And so I do all different materials. The interesting thing is that the attraction to bowls initially, and still quite a bit, is really strange to me. But it's basically just the act of becoming one with creating things. And that's really what's going on there. Is I can just go completely into the mode of making and the mode of experiencing that process. And so I honestly don't know what the hell to do with all these bowls. And so that's clearly, I don't make them to have more of them. I'm hoping that someday some people will want a few of them. But it's really about that creation process that's really the magic for me, and seeing it emerge and then learning through that process about my materials and learning about the history of the wood and seeing the wood's history, seeing how it's changed in time. There was a beautiful piece of wood that in a little forest that where they cut down most of the trees when Julia was born, And I recently got a round of wood out of that. And you could see this tree took 70 years to get this big, and then took 24 years to get that big. And you can just count out the rings. That's when Julia was born. And so it's seeing, so it dendrometry, no, it's the rings. Dendrometer is not, it's what's the counting rings? It's a science of rings. Anyway, looking at rings, it's a whole science, is looking at the tree rings. And I think a lot about tree rings. And so I just, I can just kind of space out on that for a while too. I don't know if that answers your question, Cynthia.
Any other questions?
I'll just say, it sounds like we all need to have you creating our prototypes for us, since you have all those materials.
There you go. Very creative.
Yeah, if you saw my front yard right now, you'd say I have a lot of materials. I am. There's a whole science of large woody debris, and so my front yard is very much an example of large woody debris, which I think is ecologically, something we should be proud of. The neighbors may not think that. I'm not sure.
Good carbon storage place.
Exactly. But of course, I make all those chips. Which,
Oh, yeah, that's
anyway, okay, guys. Well, any other questions or thoughts? Any insights?
Leah, Jeff, Ronnie,
What is Sarah? Is Sarah really there, or is she just a black square?
Sarah's there.
I am really here.
Hey, Sarah, good to see you.
Good
Sort
to
of.
see you too, John. Thanks. It's a great talk, definitely inspiring. I have not considered myself an artist till about 3 weeks ago. So this is an incredibly interesting series for me to kind of wrap my head around. Thank you for your very philosophical introduction.
Oh, well, go for it, Sarah. Have a great time. What type of art are you making?
That's under debate.
Oh, well, okay. Don't, it can be for yourself. That's fine. Good. Well, hey, thank you all for your attention today. And it was fun to kind of prepare for this and try to figure out what to say. So I hope we got some ideas sparkling around.
Yeah, definitely. Thank you so much, John. And thank you all for attending. And next week, it'll be Chet who will be talking about his art. And I have told people at the Art Center that if they needed help from engineers, you guys were the ones to talk to.
Oh, yeah. We're always happy to make stuff.
Exactly. So it's great.
Good. Well, thanks very much, y'all. And take care and enjoy the beautiful afternoon.
Yes. Thank you much.